Essential mathematics is a scheme that we introduced in 2001 to remedy students' lack of basic skills in manipulations. The reason for that was quite unexpected. We introduced a computer algebra system in the first year, and we thought that that would simplify student difficulties in handling computations. But it had an unexpected side effect. It turned fractions into fractions, as opposed to a string of digits on a display of a calculator. And we realized that the student didn't have any intuition about fractions. Then the computer algebra allows you to treat prime numbers as prime numbers, to figure out whether a number is prime or not. And we realized that the student couldn't tell the difference between a prime and a composite number. And so all in a sudden we discovered that this computer algebra actually exposed this vast lack of basic manipulative skills. And so we tried for several years. I introduced various remedial activities within this computational course. It was a program called Baby Maths, and it had a kind of logo with toys and everything. But the students were not taking it very seriously, and what the student needed to do is actually to do a massive amount of calculations, the type of calculation that they should have done in secondary school, particularly in the early part of secondary school, but they hadn't done it. And so after various contortions, soul-searching and wrestling in various directions, then we finally realized that there was only one solution, which is high expectation, sky-high expectations and zero tolerance on minimum standards. And so we decided on a basic syllabus, on what is GCSE mathematics the way we would like it to be. And so, well, first of all, basic multiplicative arithmetic, prime numbers, greatest common divisor, prime factorization, that sort of stuff. Then fractional calculus, quite complicated expressions to help the student develop the ability of some kind of stamina and the ability to check whether or not the calculations are correct. And then manipulation with polynomials, with square roots, and the intellectual peak of the course was the solution of the quadratic equation, which I believe is normally done at age 16 or something. And we didn't want to go beyond that, but we set this very uncompromising examination on it, and we made it compulsory for progression in the second year. This was a bit of a shock for the system, because the system was not prepared to have absolute hurdle. The examination system does not work that way. You have a certain number of units, and you have to pass a quorum of units to progress to the second year. But we introduced this absolute hurdle. So if you don't pass this exam, then you can't progress to the second year, even if you get 100A in all the university examinations. So the faculty board was quite nervous about it. They asked us to offer 7 attempts, and so we did. And then we started introducing this scheme. We had a multiple choice exam with a pass mark of 80%. And we decided on the standards, and then we took the plunge. The first time we ran the scheme, we had a failure rate of 96%. I was the only person in the department to be relieved. I thought it was going to be 100%, whereas all my colleagues were actually shocked. And then, of course, there was a big turmoil, because we realized, well, wait a minute, if we don't do something about it, then next year we have to close down the department, because if we fail all the students, then we're not going to have the income. And actually that brought into the scene quite a lot of educational rigor, and so we started dealing with the problem of student supervision. We started dealing with the problem of compulsory attendance to the various initiatives that were supporting this course, and eventually over the years we developed a format for this course that delivers a pass rate at around 90% over the 7 attempts. The students who don't manage to pass this essential maths after 7 attempts normally have deficiencies elsewhere. Occasionally there have been students that actually have been precluded to progress to the second year just because of that, which it serves as a basic deterrent. The great pleasant surprise that I found in running this exam is that there's sort of intransigence and asking the student to do an unprecedented volume of calculation fire their imagination to some extent. I've seen a student turning up at these exams that they had passed already, and they didn't have to be there, and they say, well, you know, I wanted to check whether or not I was still fit, these sort of things, or seeing students engaging in very complicated calculations just for the pleasure of it. So I think this is a good lesson to learn, to have very high expectations and to have sort of a level of intransigence on minimal standards, on few basic items. Ask a lot to the students, and if you ask the students a lot, they will give you a lot.